Hey everybody, in today's lesson we're going to look at angle bisectors and perpendicular lines. There is a section that was going to use protractors and compasses to bisect these lines, but we're going to use an example of just drawing our estimated line and then bisecting it. So let's get going on angle bisectors and what this actually means. So it's a segment, a ray, or a line that separates two halves of a bisecting angle. Bisecting an object involves dividing it into two congruent, which means equal, parts. When you bisect an angle, you divide it into two angles of equal measure. When bisecting a 76-degree angle, it divides into two. Now we would take 76 divided by 2, and we'd be getting two equal 38-degree angles. So to bisect the angle, you're dividing it by 2, so you're halving it. Now, bisecting an angle can be done using measuring tools such as protractors and compasses, which we're not going to be looking at. And then, or by manipulating the material itself. So you could do folding, which would be able to fold it in half and then quarter it and then so on. In the example below, it says you're ordering a large pizza, but you would like more pieces than the usual 8. So you ask the restaurant to cut the slices half their regular size. Draw a circular pizza. Draw in the 8 perfect equal slices with one color, then perfectly cut each slice in half. You will need a compass, protractor, and ruler. Well, we're going to estimate this, so we're going to just be using a ruler. Now, you can also use any type of straight edge to get this estimate. So I'm going to magically pop up our 8 equal slices, but I'm first going to let us look at 4 and then watch the transformation. This is what it would look like if we divided it into quarters. So we split it into 4 equal pieces, and you would have 90 degrees at each corner. So where the two line segments meet, you would have 90 degrees all the way around. Next, I'm going to divide it into that 8 so we can see what's going to happen with the angles. Now we've split it into 8 equal slices, and we know before when we had it split into 4, we had each corner equaling 90 degrees. Well, a way that we could figure out what each one of these angles is taking 360, which would be the entire circle going all the way around, and dividing it by our number of slices. So we have 8 equal slices. So if we did 360 divided by 8, we would get 45 degrees. And this would be for each individual slice. The next thing we could look at is splitting each slice in half. So we're cutting approximately in half here. So let's see what this looks like. Now I've taken this further here, and it kind of looks nice. It looks like a dream catcher, and it's taken all of the 8 slices and divided those in half. So what I did was found the spot that was approximately in the middle, so around here, and then I found the spot right across that was approximately there, and I made a straight line right across that point. Now, to figure out what that angle would be, well, we knew each slice, so out of the 8, each one of them was 45 degrees. If we want to figure out now what each individual slice would be, we could take 45 degrees and divide it by 2, and this will tell us that each individual slice adds up to 22.5 degrees for each. And that's the new slices. So that's an easy way to divide it up. You do 4 lines, or all the way up and all the way across. That's going to split your circle into 4 different pieces. Then we can go into 8, and then we're going to go into 16. So if you divide your circle up into 16 slices or 16 pieces, then you're going to have each piece equaling 22.5 degrees. Now, are there other ways that we could have solved this problem? Well, one way would be is if we took the paper and folded it, we'd be able to divide it into this number of segments. We could also use cuts, so we could cut all the way across and keep cutting it into its individual pieces. Move over to the next page. And as I said, we're not going to look at creating bisectors with a compass or a protractor, so you can cross these parts out. But we will use an example here. Instead of using the protractor and the compass, we're just going to look at drawing what approximately would be a 65-degree angle. Now, if I just draw a line straight down and straight across, we know that this would make a 90 degrees in the corner. If I split this in half, this would be each 45 and 45. So if I wanted a 90-degree angle, what I would probably draw would be a 60-degree angle. Well, I want a little bit more than what my 45 is, so I'm looking at 15 degrees more. So I'm going to be approximately somewhere in there. So I could get rid of this line and get rid of this line, and this would be a good estimate for what my 65-degree angle would be. So we'll call this 65 degrees. Now, in order to split this in half, what we'd be doing is trying to do our best to draw a line down the middle and then look at what each angle is going to be. So in this way, we're not looking at drawing the most accurate. We're looking at drawing it so that we can get an understanding, if we split it in half, what are those angles going to be? Well, if we take our 65 and divide it by 2, we're going to have two angles that are 32.5 degrees for each. So that's the big thing we're looking for, is understanding how this will affect it if we split it in half, and then what our new angles are going to be. So don't worry about drawing it with a protractor or a compass. Now we're going to look at finding perpendicular lines. A parallel line is two or more lines that continue without touching each other. So they would go on and on forever without touching. So line S and R would be an example of parallel lines. They could continue on forever and never run into each other. Perpendicular lines are two lines are considered perpendicular to each other if they form congruent adjacent angles, a T-shape, and the angles created by their intersection is called a right angle. Perpendicular lines would be right where they meet here. It creates a 90-degree angle at the corner there. So line T and line S would be creating those perpendicular lines. So it's that 90 degrees in the corner is what helps you to determine that they are perpendicular. Knowing that S and T create perpendicular lines, the angles formed between R and T, so R and T, so T is going down, R is coming across, these as well are going to create perpendicular lines. The angles formed between U and S though, so we're looking now at S and U, so the line coming across here and the line going down here, so where they meet are not creating 90 degrees. So S and U are not perpendicular. The angles formed between U and E, so this line going straight down and this line going across right where they meet here, so U and T, are not 90 degrees, so U and T are not perpendicular. And that'll bring us over to our next page where we're going to look at triangle properties. Triangle is a three-sided plane or two-dimensional figure. The sum of the three angles of a triangle is always 180 degrees. So if I added A, B, and C together, I'm always going to add up to 180 degrees. In a triangle, the exterior angle equals the sum of the two interior opposite angles. So if we're looking at A plus B plus C, it is going to add up to 180 degrees always. If your triangle does not add up to 180 degrees for the angles inside the triangle, then something is wrong with your triangles. They should always add up to 180 degrees. Now that last part says that C and D, so if we're looking at exterior angles and the interior angle, we're looking at C and D all the way across, this is going to add up to 180 degrees as well, because we're looking at a flat line there. Below it says try this. Find each angle marked with the letter, so we're looking for B and A, and give reasons for your answer. Well, to figure out the angles inside the triangle, you need to have at least two of them because there's only three. So if we only had one angle, which is the 70 degrees, so if we had this angle and did not know this angle, we would not be able to solve for this. But by having that 120 degrees, we can go with 180, subtract 120, and this will give us an angle of 60 degrees. And this is what type of angle? It would be a supplementary angle. So we know that B equals 60 degrees. So from here to here, we have a 60-degree angle. We can now figure out what A is going to equal, because A equals 180 subtract 70 subtract 60, because all of the angles inside a triangle add up to 180 degrees. So A is going to equal 50 degrees. And this is going to be the sum of all of the angles in the triangle that helps us add up to 180 degrees. Below it says, a carpenter needs to cut a 2x4 piece of wood that will fit into the corner as shown. So we're looking for a 2x4 to fit into the corner right here. If one end of the wood forms 50 degrees, so we have from here to here, which is a 50-degree angle with one wall, and at what angle must the other end be cut? At the indicated angle. So we're trying to figure out what this angle is going to be to lay flat against the other wall. Why must that end be cut to that measure? So we need to figure out this one missing angle. If we know that this is 50 degrees and this box right here represents 90 degrees, we can figure out our last angle. So what we need to do is figure out, well, our unknown equals 180 degrees, because that's what all the angles inside a triangle add up to, subtract our 50, subtract our 90, we're going to get our unknown angle equaling 40 degrees. And that's the sum of all of the angles. If we add the 40, the 50, and the 90 together, we're going to get the total of 180. Now, if we are also asked to figure out this angle, so let's just call this B, we know a flat line adds up to be 180 degrees, so we're looking for a supplementary angle. So we have 180 degrees, subtract What we found out our question mark was 40 degrees. So B equals 140 degrees for that supplementary angle. Now that's going to finish it for the lesson today. Please make sure you're going into the work booklet and completing those pages assigned. And if you have any questions, please send me a message on Teams or ask me in class.